Welcome again to my messy workbench here. I was at an estate and got some parts, and here we are looking at the Alliance Tenna rotor. This is the controller. I cleaned it up a little bit, and here we have the rotor itself. From what I heard, you can use it either horizontally or vertically, so you can rotate in either direction depending on how you install that rotor. And haven't checked out that rotor yet, if it works or what the situation there is, so we're gonna explore that. So the first thing we need to do is hook up the control wires and plug in the cable there. The control wires are right down here, and they are numbered 1, 2, 3, 4, and right over here we also have them somewhere numbered. I need to open that up more so we can actually look into it. And this here apparently is the button that you push in to calibrate where the position is of the rotor. So we're gonna explore that as well. And I think if the rotor works, that would be awesome. Probably with the age, we probably have to dig into it and re-grease it so it actually lasts a little bit. But first, let's see if it actually works. Just removed one of the screws on the cable tensioner, and it just sheared off the screw. It's an aluminum screw, and the nut was just so stuck it sheared it off, so we have to replace those ones. Probably gonna go with stainless steel because that's what I have. That's a very interesting way of making that line thicker, so just electrical tape. Yeah, and the contacts are a little bit corroded. The gasket definitely needs to be replaced. So yeah, to weatherize that will be an interesting project. First I was wondering, because there are no numberings right around the terminals, which one is 1, 2, 3, and 4, because we have nice numberings on the control unit. And I noticed right here on the sides in the casing we have the numbers. So we have the 1, 2, 3, and 4. So I'm just gonna go with the colors of the wires, strip the wires right here, and then connect it to the controller box. So I went ahead and wired it up. So we have one pink on pink, purple on purple, brown to brown, and white to white. And it doesn't matter which color you have, it's mainly that the numbers correspond, because electricity is colorblind, just like me. So if I would install that, I would use a little bit thicker wire gauge, I think, and also make a nicer terminals, like some nice crimps there also. But let's go ahead and, oh yeah, other things. That being a metal case and only having a 2-prong plug, come here plug, right there, it probably wouldn't hurt to upgrade that as well to be a little bit more in compliance with the current electric code. But anyway, let's just keep on going and see if that works. Let me plug that in and I'll come back. Okay, here we are, plugged in. Everything is nice and quiet. Let's turn it. Whoa, it worked. Go to north. So it lights up here nicely. The clicking noise in here is totally normal. So what's actually happening is that in here the motor has a disc that spins around, and once that disc turns all the way around, it has a switch that it closes, and one of the wires, I haven't checked which one it is, then closes the circuit and makes this disc move one position. That's a click. So every time you hear a click, it's one rotation of the motor. And of course, because of the gearing, the motor spins much faster than the mast will be spinning. So let's go to the very far edge. Oh, did I mess up here? Let's see. Turn all the way around. Oh, so we can only move it north to north. Okay. That's the first time I'm messing around with rotor control on rotors, so I'm fairly new here as well and exploring. Definitely a nice late 60s, 70s kind of styling. Definitely would look nice enough to put in the living room. So right there it tries to rotate more. So I'll have to see if definitely have to figure out how to calibrate that. So here I can turn it all the way to northeast. So if you turn that to north, it's like a gap of no click. Let's say this is north. So what does this do here? Oh, that's nothing. Never mind. Not sure why that was written there. Let's see if you can figure that out. So that's as far as I can go. Kind of manage it like this. Ooh. Uh-oh. Shit. I shouldn't have done that. Oh, I think I did something bad on the knob. It doesn't rotate. I need to dig that into that. Okay, I took off the screws. There's that little nice trim. Isn't that cool? Definitely living room worthy. And now we should be able to pull that off, which I can't do with one hand. Can I? Maybe. Yeah, I'm gonna put that aside. Alright, I just pulled that off. I could do that without removing the knob, so that's kind of neat. So here we have our incandescent light right there, that nicely closed. It's actually pretty cool. Oh, there's a capacitor. As yellow as it is, it looks... Oh, there's shrink tubing too. That definitely means this one has been serviced. And let's look a little bit in there. So that's obviously original. The capacitor is redone. That is pretty neat. Everything else looks good. Oh, grease isn't too bad either. There's still some grease on that. And right there, Oh, let's turn it around. You can see it. So right there is the magnetic switch that if it pulls, it pushes that down and it makes this whole mechanism move, I think. I think the motor needs to be running too. Also, yeah. So one thing I have the problem is that knob is slipping. I was thinking that I might see something where the knob needs to be tightened, but I'm not seeing anything. Houston, we have a problem. Let's see under there. There was like this weird opening thing. Is that a button? Oh, it is a button right there. So you're basically grounding this here to ground. That's what you're doing. And that does wire number 4, it touches to ground. And let's just trace that through. So wire 4, that's this. Yeah. So wire 3 goes to the light bulb. It goes to the transformer on the blue one. So that's the central tap. Wire 4, where did that go? That go upstairs to the solenoid here. So when we ground that, the solenoid probably pulls in, makes something move. A lot of stuff going on now. Yeah. Hold on a sec. Okay, kids, don't do that at home. I plugged that sucker in and just trying to figure out what the heck this does. That doesn't do anything. Let's see if we can do that switch there. So right there I'm bridging it over to ground. Nothing. Now I don't have a clue here. That kind of stinks. So I got here a mechanical helper. Hopefully it works out fine. So it's still plugged in, first of all, so we have to be careful. We see the power goes right in here and it connects. Oh, it connects with this case too. So one goes right in here and the other one goes in tap 2. So it doesn't go straight into the transformer. That is quite interesting. I never actually checked if that is 24 volts or more than that. But the whole thing is running in AC. So if you do voltage measurements, you use AC for that. And that's easy to figure out because all you see is a transformer. There are no rectifiers. So rectifiers are just basically 4 diodes that rectify the AC current. So let's go ahead and see what we get here. So holy shit, if that's metal and that, wow. Just thinking of this. I don't know, maybe you don't ground it, I don't know. Let's see here if we find any voltages on those ones. Nothing of notice. No. 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 Okay. Let me unplug this again. Let me swap that around and really trace down where the wires go. So power line goes right to this spot here, and the other one goes, goes to that one. So those are the two that we want to check out. It doesn't do that rotating thing now. And I plug something in. I don't want it to move around, so okay, that's good. I said don't do that at home, kids. So we are plugged in again. AC doesn't have a negative or positive, so it doesn't matter. And we have 120 volts right there, diddle-dee-poo. Okay. And on this case, 100 volts, yeah, some drop down. This way, we have 3 volts, whatever was dropped down there. That is interesting. Slightly scary. Because that means neutral is on one of them. Let's do this here for a sec. Let's go unplug that guy. Do continue checks. So if we do the continuing check here, obviously we don't get anything. And to the case, I was wondering, did we get something? No, nothing. Which is kind of good. So this prong goes here. The other prong goes over here. So why the heck did I get still 100 volt against that? Because in theory it should never have any voltage on the case, because you can see here we have the old style prong. There's don't even have one that's wider, so you can guarantee that the neutral is always on the neutral and the face is on the face. So if you don't know anything about electricity, neutral is at the same potential as ground should be. So that means if you touch neutral and you're standing naked foot on ground, you don't get shot. But if you touch the other one, face, then it's not very healthy for you. Let's put it that way. However, even if your outlets and the plug have a directional plug-in where one side is bigger so you can plug it in, or because it has the ground pin so you can plug in, don't ever rely on which one is the neutral, because somebody will wire the outlet wrong. So take both neutral and ground as neutral and the black wire face as powered and deadly. So what I'm gonna do is I just want to explore what the heck is going on here in that circuit. Unfortunately, it's not that easy to do. So this goes to the light bulb. The light bulb goes then over to the center transformer, and those two transformers go, one tap goes here. Would be interesting. First unplug, yes. So power goes to this one, and this tab also has the brown to that, so that's the primary and that's the primary. Yeah, so 110 or 120 volts, whatever volts we have on here, goes on to this side, the primary, and the secondary. So what we have is maybe, well, you can see that's probably a 12 volt light bulb, so it's probably a 12 volt tap right in the center. So that's 12 volt, that is ground, and that's 24 volt. Or if you want to say, you can say this is ground, this is negative 12 volt, and this is positive 12 volt. It really doesn't matter. What the thing is, it's the voltage differential between those two wires and those two wires is 12 volts, and the right outside ones will be 24 volts. Okay, so the 12 volts we purely have for the light bulb, and the 24 volts maybe we have for the rotator. Let's see here. What's going to the rotator? So we have this here is the solenoid that clicks, so that's what indicates whenever we do a rotation. So if we trace back the wire that goes to the solenoid, so we have one in the center here, we have one that goes down to pin, white wire, that's pin 4, and we have the red one that goes down to this thing. So I would say, not looking at the manual at all, pin 4 is where it sends us the signal that one rotation has occurred. And sorry, one sec. Yeah, that's it. Pin 3 here, I don't know, can you actually see that? Pin 3 here has the black wire of the light bulb. So since, let's just assume let's just name that ground because it's black, and that goes also to the bottom of the secondary solenoid transformer. And then the center, the blue line, goes to the other side of the light bulb. So what I would say is the center is our plus 12 volt, the black one is ground, so that would light up the light bulb when this ground pin, yeah, when the transformer is basically operating. Oh, so that means probably since the yes, I'm still unplugged. Since the 112, 120 volts goes to this plastic thing, I bet there is a switch in it that causes, when this is aligned, causes the transformer to be turned off. So it's an automatic turn off of the whole thing, so the transformer doesn't have to run all the time. So as soon as you turn the knob, the transformer would turn on, and now we have ground in the light bulb lights up again. So that's what I assume is happening here. We probably can figure that out some way later. So we have a whole bunch of tabs right there. So that's the ground then from the light bulb as well as the controller. Now I think the controller is ran with the 24 volts up there. It's the red one. So if you go down there, the red one is also connected to the solenoid. So if we say let's see, this here goes over here. Okay, the green and the red one, so pin 1 and 2 are across the electrolyte capacitor. The electrolyte capacitor should have a positive side and a negative side. Oh, no. You don't? Oh, see a label there. Should have. No? People, AC. I need to think about AC, so it doesn't matter. You don't have positive, negative. Remember that. It's AC. So if I say negative 12 volt, positive 12 volt, positive 24 volt, let's say this is neutral, the face for the 12 volt and the face for the 28 volts. Anyway. Okay, so where are we? So still wonder what the heck this button is doing, because this chassis means it's connected to one of the, yes, let's see that. So we still have continuing. So if you go to 28, am I getting here something? It's kind of squealy. $28, 24 volts would that be? Oh, wait a moment. Yeah, well, I'm gonna have to measure voltages again, because I'm gonna measure continuing. We're gonna have a connection across the secondary winding too, so we won't be able to really tell with that. I would have to measure resistance and whatnot, so let's just go ahead and put some juice on that. Although we won't get anything because it's not running, right? Because let's trace that again down. So this one is over, holy crap, like this here. So one is here and one is there. So that has our 122.4 volts. This here, yeah, has nothing, which is where the brown one is. and that's the other brown one. So if we would connect those two, then the whole system would be on. So that connection is off. Okay, I'm rambling here, I know. So let me show you right here. What I'm looking at is right here are the two fingers, and this one goes to the thin brown wire to our primary coil. The other one is our thick brown wire that goes to the power right here, and that is the other side of our mains power, which goes to that brown one. So what needs to happen is these two contacts here need to close, and I'm not sure what's going on right now. They are not right now closed, right? If we go ahead and do the beep test and we connect the beepy thing, nope, no beep. Okay, so let's look at the mechanics there. So normally we turn this dial and it would turn something in there, which it doesn't. Again, our knob is loose. So right there. I pulled the knob off. So right here, can we see that? So you can see the knob turning, but the center stem is not turning, and we have just an alloy wrench there that we need to tighten, and then we are still again back in business. So let me do that, and then we can explore this device more, and I can do some voltage measurements, and we can figure out what really is going on with that thing. Let's see if I have an Allen wrench of that size handy here. Just move it up. Are you the right size? Oh, yes, we are. So if I unscrew it, there we can see the whole thing. Yeah, it was stripped. Yeah, we did some bad thing there. Not spinning that too far. An interesting thing is this whole stem is just perfectly round. Really could have made a side flat so things hold better, but well, whatever. So we are north right now. Let's put that there. So let's go ahead and tighten that. Anytime. See, now we can turn it again. All the way to here. Let me turn it all the way to here. Sweeto! Oh, so it has a nice little metal trim design there, and in order to that metal comes there, In order to keep that away from this metal and give you some electrical safety, they had here a piece of paper that's just stuck right there to protect it. Of course that came off. Yay, yay, yay. Do we trust that it just stays in there when I shove it in? Or should we do something more? Yeah. Good enough for the US, I think. Oh yeah. Now it looks all awesome again. Let's explore this voltage things more. Definitely want to have it at a solid base. Let's get these cables out here first. Switch it over to AC. And as soon as I plug it in, it should be rotating. Right? There we go. So here you see it clicking all the time. And (26 volt), and whenever it goes down, whenever it moves once on the click, it's 0 volts. So it's definitely, when you cover that, shorten that, that moves that does the calibration. So if we just check the voltages up here, nada. Okay. So that was about here. Oh, I should have flipped over there. The full range. I think I definitely need to read some manuals here on how this whole calibration thing works. Oh! So right there you see this here. I'm not quite sure what that does. So I said 3 is ground. If 3 is ground, Ha! There, this time I used this switch here in order to calibrate that. So we are exactly that position, so it goes to the far side. Let's rotate that thing around to north and see if we get that again. So 1 and 2 have 38, 37 volts or something AC. Get better readings on this side, okay? So here, we're not totally done yet. You hear the humming noise? So let's get to the end position. So now we're at the end position. So that was counterclockwise. Now we're turning it all the way clockwise to north again. I saw a pretty cool manual. I'm gonna read that to figure this out. What the heck? Hey, why did we get stuck? This got weird because now we hear it is sending power, but the motor is not moving. So if you are moving this it would just move the indicator. Not sure why it started all of a sudden. Now let's just see if we can get it calibrated. So right now I have counterclockwise all the way to north. Interesting, the motor is now pointing downward. That is something new. Something tells me there's something not quite right. I think this motor kind of jammed up. Tiny bit of moment now. Probably have to look into that. How about I look up the manual and get some more information on that and come back later. Okay, I printed out the electrical circuit of, actually this one is the U100. I have the U-83, but they're all pretty similar. So up here is the rotor, and down here is the controller, and here we have our 4 pins. So if you look at the rotor, right here is the switch whenever a whole rotation goes through. So number 4 is the signal or the switch. Then number, I think those are combined. I don't think, I'm not sure if there's a dot there, but maybe not. Not 100% sure. So 1 and 2 are the two different directions that the motor goes in, and 3 is the ground. Oh, sorry, as they were mentioning right here. So and right over here it says 29 volts, 24 volts. I mean, back then it was also 110 volts. So now the whole voltage has gone up too. So that's a little bit rough. Anyway, so an interesting thing that I noticed is all the way back on the U100, it mentions that right here after 96 they added where was that? No, where was that? I was reading it somewhere else. Oh, right here. That's where I was wanting to look at. After 96, a thermostat in a transformer was added, and so operation is limited to 4 minutes. So if we don't have that, we probably still encounter that issue of overheating. So we definitely don't want to run it too much. And as you see, I plugged it in and it's running again. I think the problem was the motor was probably getting a little bit too hot over there. So let's see if we can calibrate that again. So we rotate. One book was mentioning, there was multiple manuals, and one was mentioning you shouldn't rotate all the way across. Definitely what you shouldn't be doing is changing direction without letting the rotor stop. So let's go ahead and go to the extreme. Okay, we need to move the rotor once more, there. So it is flat away from us. Can you see it right there? That little thing here. So let's go ahead and try this out again. So right now I'm south, so theoretically it should be pointed flat forward. Let's see if that's happening. Yeah, that looks pretty good. So let's go ahead and turn it all the way to the north, going the same direction. Yeah, nearly. Tiny bit sloped down. It would be nice if the rotor could go a little bit more than a 360, 358 degrees or whatever. So there's definitely a couple degrees that it doesn't reach. And as you can tell, the rotor is not totally fine grained, and it does have clicks. You would have to use a potentiometer. Probably about time to give that a little rest. So I'm gonna unplug that. Let's screw that thing together. So that's working out quite well. Figured out our weirdness there. So the controller here looks pretty decent. That's nice. So let me clean up the box here and the controller a little bit and assemble it, and I bear you that. Okay, I assembled that, One thing to keep in mind if you clean it out, the underside edge of that trim is pretty sharp, so it kind of caught me there and cut my thumb a little bit. So let's go ahead and rotate that. So it's supposed to take like about a minute. You can time it if you want to. To rotate around. So I definitely want to go through and clean out, not clean out, but recrease that, I think. I also have another motor that I can check out as well. Pretty good, I say. Was quite a while since I started this video. Life got in between, and especially this water heater there. Water heaters do kind of get a little bit corroded, and there was a corrosion that I did not quite pay enough attention. That's right here. And what happened is it corroded so far the whole threads disappeared here, and obviously water sprayed out. The reason for that happening is, if you know a little bit about water heaters, well, that's totally off topic, but here we have a different metal than up there, and there's a galvanic reaction on it. So you have these special nipples that have plastic in it that's supposed to be reducing that. Like right here, you can see the plastic that should isolate the galvanic process, but that didn't happen on this one. And so you see the threads here. Right here was also threads on it. That's the other side of that metal piece. I think called nipple for it, and that's what's screwed into the water tank here, and so that just corroded totally off. On a weekend day, Saturday, I was down here, got some winter clothing, then we went out hiking in a nearby forest for an hour and came back an hour and noticed that the water was spraying out of the water heater right here between this here, and of course it was flooding our basement. And it's amazing how much water just runs out there, full pressure into the basement. Our lucky part was that we have stuff in tubs on this side, so one tub was actually open and it filled up the whole tub. Otherwise things didn't get damaged. Also, if we look right over here, I have my workbench, and you notice that there are tabs over them. That was really a saver. The reason why I have a tabs why I have tabs over them is above it is the dryer vent, and I was worried that the dryer vent would cause some condensation inside the vent, and then that condensation would drip down. I haven't seen that happening yet, but with the water pipe, water was splashing onto the desk, and there was a little bit of water standing on it, but it kept away the water from my sensitive equipment, which is quite fortunate. I mean, there's an oscilloscope, network analyzer, so things would have been expensive if I would have to replace them. Luckily we didn't get too much damage. Got a lot of hassle fixing the issue, and then of course the next day in the morning the heater wouldn't work either. We had to troubleshoot that and got that fixed as well. But now we got a new nipple installed, sorted that, and we should be fine for now, at least until next problem happens. Anyway, so let's go back to the rotor and look at upgrading the rotor, specifically the power wire. I want to change out to add a ground to it, just to make that safer. That is actually not the rotor, but the rotor controller, to add a 3-pronged wire, so the casing is grounded as well. And then we'll try out things a little bit more on the rotor and talk about it. So before I close this case here on the control box, again, that's the model U-83, and what I did is I went ahead and replaced the power cord, so I have a ground here, because this metal piece is exposed and you could touch it, and normally it's totally fine, but if one of the power lines wires breaks off and touches the metal housing, then the metal housing will be under voltage, and if you're touching the metal housing, you might be the path to ground, and that wouldn't be great. So according to standards, at least in Germany, I've grounded that case, so that should be a little bit safer on that. So again, if we want to go ahead and compare on the chart here, so on the chart we have the line power going into the transformer, and then also through the contacts that are on the dial there that close it and makes the whole mechanism go until the rotor is at its proper place. Then the contacts open up and the transformer doesn't use up power. So in an efficiency wise, this is much more efficient than nowadays, where our devices always draw a current, at least in standby mode. I did measure the voltage across here for the that's the which one was that? That was the 100 model. The voltage is 29 volts AC or 30 volts AC. I did measure 40 volts, but they also have 117 volt AC, and we are running now 120 or something more. So that all changes those values. So 40 volts, I guess that's probably still all fine and okay. Not much you can change there anyway. So right here in the middle is the windings. So in the middle, that would be 20 volts. Maybe it should have been, yeah, 20 volts. Goes to the light bulb there. That lights up the light bulb. Now if you look how the circuit works is the transformer I already described when it's on these contacts here. Then we also get the power over to these lines to drive the motor in our rotator. And the rotator has a switch on it when it does one turn of the shaft. So it's not the whole mast rotating, but it will be multiple times. It switches a switch here and closes that. So what that does, it closes the solenoid here to ground, just like that manual switch which we see down here. That manual switch also grounds that solenoid to ground. So that activates the solenoid, and the solenoid makes the whole mechanism move on. So again, right here is the solenoid that gets pulled down, and this whole mechanism is rotating then one more step. And that's the clicking noise that you hear when it's running. So and when it's at the end, when the rotor can't rotate anymore, but the dial isn't at the end, that's why you have this manual button, so you can click the mechanism to the right place until the light bulb turns off and the whole system is done moving the rotor. Because if you don't do that, it continues using power and the transformer gets warm. This here has a thermostat on it, and I don't think our model here has a thermostat that protects the overheating there. So that's definitely something to keep in mind. Anyway, so if we look here comes our power cord. I have a green wire, that's the ground, and that power cord actually had a shield even. It was a fancy power cord. I probably shouldn't have used that one for a simple duty like this, but need to prop that up a little bit or something so we have a better angle here. So these two green shrink wraps mark the power line, so it goes in here. That's just a terminal that connects the other wire, the brown wire that goes to the transformer right over here, and this one goes to the contact. So those two arms are the contacts. So the mechanism causes this to close, then the other contact arm over here is a brown wire, right? This one here goes also to the transformer. So that's the 120 volt side, and here we have the 40 volts side with the middle tab. Again, the middle tab just goes over to the light bulb, and the light bulb is where this wire 3 also makes it to ground. Anyway, so this is the whole mechanism. We can go ahead and try it out again. Let's go ahead. I've plugged it in already, so just turn on the power. So right now you hear it, it's not all the way to the end, and if I close this, we move the mechanism. There we are. Definitely decent sparks that we're getting. Okay, so this is the modification that I made to it. The grease looks pretty good, so don't really need to do much more on that. Whoa! Stupid me. Don't do that. Okay. So everything looks good. The capacitor actually looks fairly new, so somebody replaced that. I'm gonna put the housing on, and then this control box is done. So now the rotor control box is assembled and ready to go. There's the rotor motor. On that one, I want to open it up, check on the grease, try to put on the replacement weather cap here, see if we can figure something out there. So that's working again. So on a follow-up video, we're gonna dig into this rotor motor more. And then I also have other rotors that will be in another video in the futures, that we can go in and explore with those ones. Those are totally different rotor controllers and rotors, so that will be exciting as well. So until next time, we'll see you. Bye bye.